Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. All of you know that Unacademy is the India's largest online learning platform. I'm welcoming you all to this beautiful online learning platform. Okay. Now we are happy to announce that we start the online training for the students who are appearing for GATE and Engineering Service Examinations. Now here your classes are taken care by India's top educators and experienced persons. And about myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Now, see this. First we check how to get this Unacademy learning app. Just go to Play Store in your device. Just type Unacademy in that. By typing Unacademy in that, it will shows the Unacademy learning app like this. Okay, once it will open the app like this, just click on this button install. Click on this install button here. By clicking on this install button, it will install the Unacademy learning app into your device. Once you open the device, it will shows what are the different courses available in this. What are the different courses, and in each course what are the different subjects and who are the top educator handling that subject. You get that information here. See why we are claiming educators are toppers. See, Tiwari sir, he is IIT topper. Ankit Goyal sir, he got 2 times All India first rank in GATE electrical and he obtained President of India gold medal in IIT Indore. Sanchit Jain sir, he is the top, he has more than 8 years of experience teaching the computer science students. Jaspal Singh sir, he is ex-IAS officer and he got in All India 4th rank in IAS. And he is ex-senior faculty in MedEasy also. So that's why we are claiming that our educators are toppers. Okay. And here experienced faculty is there, topper in IIT is there, topper in GATE is there, topper in IES is there. Here I am showing few more toppers who are a few more top educators from Unacademy. Now we are happy to announce that recently we started 2 new batches, one for mechanical engineering, other one is for one for GATE 2023, other one is for GATE 2022. Now Ascent batch for GATE 2023 and Evolve batch for GATE 2022. Now this is the Ascent batch for GATE 2023 mechanical engineering, and this batch started from 22nd February 2021. 22nd February 2021. And don't forget to use my code VRAO10 during subscription to get 10% discount. And next, see this, there is a Evolve batch for GATE 2022. This is for mechanical itself, and the same faculty, same team who are handling the GATE 2023, the same team is going to handling the subjects of GATE 2022. And this batch started from 22nd February 2021. Next, there is a Spark batch for GATE 2022, and this is only English batches. Here is only English batches. Here are the top faculty who are handling the subjects in that. And this batch started from 22nd February 2021. Next, there is a mission DDR. So for mechanical students, we started this mission. This is for mechanical students. We started this mission. This batch started from 22nd February 2021. We started this mission with to provide each and every student in this batch has to get a good rank. With that mission, with that intention, we started this mission. The top educators here is Tiwari sir is there, Maheshwara sir is the well famous faculty mechanical side from South End, and Menu Gupta ma'am and Amanda sir, top educators. So this is the team is going to taking care about this mission DDR. So next we move to civil engineering department. There is a ascend batch for GATE 2023 civil engineering. This batch started from 8th February 2021. 8th February 2021, and this is the team of this, and Jaspal Singh sir is there in this team. Next, eval batch for GATE 2022 civil engineering itself, the same faculty who are handling the subjects of GATE 2023, the same team is going to handling the subjects of GATE 2022. This batch started from 8th February 2021. Next, we move to computer science and information technology. There is a team for, it is a eval batch. There is a eval batch for GATE 2022. So this batch started from 8th February 2021. And in this, the faculty are Ravindra Babu sir, Sanchit Jain sir, Subbarao sir, Mallisham sir, Shweta Kumari ma'am, Vishwadeep sir. Here are the top educators and top faculty available in this team. So Ravindra Babu sir is the first faculty who started the online GATE classes. Okay. This batch started from 8th February. Next, there is a ascend batch for GATE 2023. This is for electrical engineering. So in electrical, more number of subjects is there, that's why more number of faculty. And this batch started from 1st February 2022. Sorry. I'm very sorry. Now we move to same ascend batch for GATE 2023. This time this is for electronics and communication engineering, ECE. This is the team for the faculty handling the subjects in this, and this batch started from 1st February 2021. Now we move to eval batch for GATE 2022. Eval batch for GATE 2022. This time this is for electrical engineering. Here are the top faculty who are handling the subjects in this, and this batch started from 1st February 2021. Now we are moving to eval batch itself for GATE 2022. This time this is for electronics and communication engineering, and this batch started from 1st February 2021. Next, there is a eval batch for GATE 2022. This time this is for chemical engineering. See, throughout India, hardly 1 or 2 places only chemical engineering training is available. So by subscribing this, you can get the training by online. No need to move from your location to that location. Okay, just by staying at your home itself, you can get the more benefits, more than that benefits what you are getting at outside, offline. Okay, and this batch started from 25th January. And don't forget to use my dear students, my code is VRAO10. Just use my code, you get it by 10% discount. During subscription, by using my code, you get it by 10% discount. Now, just we glance what are the different engineering disciplines available in Unacademy for GATE and engineering service. ECE, chemical engineering, ECE electronics and communication engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, civil engineering, and production and industrial. These are the different engineering disciplines available in Unacademy. Now, there are 2 subscriptions, Plus Plan and Iconic Plan. In Plus Plan, it is the basic plan. Here, India's top educators, India's best educators, strictly say, if you want to say, India's best educators are handling your classes, and there are interactive live sessions are there, structured courses and PDFs are there, live tests are there, live tests and quizzes are there. Okay, these are the things in Plus Plan. Now in Iconic Plan, by moving to Iconic Plan, India's best educators are handling your subjects. There are interactive live sessions are there, structured courses and PDFs, and at the same time live tests and quizzes. Here we are going to differentiate you from Iconic, from Plus Plan to Iconic. Here, India's best educators are taking your classes in both the cases, no doubt at all. But while writing the examinations, by providing a personal coach to you, we are taking your preparation to the next level in Iconic Plan. In Iconic Plan, by providing a personal coach to you, we will take your preparation to the next level. Okay, now this is the procedure here. Just after writing the examination, okay, whoever the personal coach provided to you, he will analyze the answer sheet. They will identify where you are strong, where you need preparation, where you are doing mistakes, okay, where you are confusing. Everything they will prepare. Based on all these things, total analysis, they will prepare a proper study planner to you, and they prepare a proper study material to you. They will provide. By using these two, every student can get success in their examinations. Okay, so that is the intention, to provide personal coach. That means indirectly we are going to identify the gaps in your preparation, and to fulfill those gaps, what you have to do, we will guide you, and we will provide a respective faculty to you, and we will conduct more number of examinations. Okay, so from all these things you are going to be getting more benefit. That is the intention here. Okay, next. Now plus subscription. Now this is available with 1 month subscription, 3 month subscription, 6 month subscription, 12 months, that means 1 year, 18 months and 24 months. These are the different subscriptions available. 1 month, 3 months, 6 months, 12 months, 18 months, 24 months, like that. Now as a faculty, I recommend the students to take minimum of 12 months or 1 year subscription, because this 1 year is required for a student to identify, to complete their preparation of all subjects, and revise the subjects 2 to 3 times, and write the sufficient number of examinations to know his strengths, and identify the gaps in that, and to fulfill that, every student required minimum of 1 year time, and the cost of this is 30,250 rupees. By using my code VRAO10 during subscription, VRAO10 during subscription, it get it by 27,225 rupees. You get it by 27,225 rupees. Now if you compare this cost with transport charges, for example, you join somewhere to taking a offline training. At that time, you need to move from your home to that location, most of the cases weekends and during public holidays. Okay, during these times you need to travel from your home to training location. Okay, for that, throughout year transport charge is 20,000 plus, and by adding little bit amount to that, you are getting the benefits more than that. Just by staying at your home itself, you can get the India's best educators classes. Next, by staying at your home itself, you can write the examinations. By staying at your home itself, you can ask the doubts, you can clarify the doubts, what not, everything. Just by staying at your home itself, you get it. That is the plus plan. Okay, and don't forget to use my code VRAO10 during subscription to get 10% discount. Next we move to Iconic plan. In Iconic plan, only 2 subscriptions, 12 month subscription and 24 month subscription. 12 month subscription and 24 month subscription. For 12 month subscription, its cost is 50,250 rupees. 50,250 rupees. Okay, and here EMI option also available. Not only here, in plus plan also EMI option is available, and by using my code, you get it by 45,225 rupees only, and my code is VRAO10. So my dear students, please discuss with your friends. And one more important thing, here we are providing personal coach to you. Personal coach to you. Okay. So please discuss with your friends, your family, your parents, and your faculty who have knowledge on GATE and engineering service examinations. Okay, what are the important subjects? Who are the top faculty through in India at present for that subject? Okay, like that information gathered. Okay, and think once and take a right decision. That decision will change your life and it will turn your life towards a good moment, and you have to get a good rank, and finally you should be at a safe position, and you have to live happily. That is our intention. So please discuss with all these things with your important members in your life and take a right decision. Thank you. Thank you very much. Now we are moving to our content, rectifiers. Already we started rectifiers previous slot. It's a previous session itself. We completed half wave rectifier with two filters, two types of filters we completed in half wave rectifier. Okay, so this session we complete the remaining two filters, and after that we go to the full wave rectifier. Okay, now so this is the last slide what we completed. Just we completed the capacitive filter. Okay, and ripple factor of that capacitive filter is 1 by directly proportional to 1 by RL. Okay, now we move to L section filter. Third one is L section filter. L section filter. L section filter. So now just to take the, so let us take it is our half wave rectifier. So now I'm going to applying this one to half wave rectifier. Half wave rectifier. This is connected to AC mains. Output of this one is output waveform. Here I am going to connecting a filter. L section filter means inductor as well as capacitor. Both are connected like this. This is L section filter. As usual, output side we have a load RL. RL. And for best operation of this, what I am doing is I am taking XC is much less than RL. First assumption. The second thing is XL is much greater than RL. These are the two important things you need to be considered here. Okay, so by taking the values like that, you get the best ripple factor. Okay, so this is half wave rectifier, and L section filter it is this one. Just it is the combination of inductive and capacitive side. This is the L section filter. Okay, now I am going to replacing this half wave rectifier by its equivalent circuit. This is the equivalent circuit of half wave rectifier. A DC component Vm by pi and a small signal AC voltage. So it is a half wave rectifier. It is a Vm by pi and it is a Vm by 2 sine omega t. Okay, Vm by pi, Vm, sorry, it is Vm by 2, sir. So it is Vm by 2. Okay, just we check. Inductor, capacitors. So at output I am connecting a load RL to this. Output I am connecting a load RL to this. RL, capacitor, inductor. So let us take this point is A and it is a ground, and this is the point B and this is the ground. First of all, for better easy purpose, I am calculating the impedance between A and G as well as impedance between B and G. So first I am calculating impedance between B and G. Is XC parallel with RL. But RL is much less than the RL is much less than XC. Because of this, impedance between B and G is approximately equal to RL. Okay. Now, sorry. See, we taken XC is much less than RL. So that means RL is greater. So, but we know XC is much less than RL. It means so now impedance between B and G is approximately parallel combination. The lowest value you get it by XC. The same way I am going to impedance between A and G. It is XL plus impedance between B to G. That is XL plus impedance between B to G is XC. So, but we know one more thing. XL is much greater than XC. Okay. So previously we defined this one. At the same time, we do one thing. So just I am replacing this with XC. Then it is easy. XL is much greater than XC. So XL is much greater than XC. So from this, impedance between A and G, AG is approximately XL. So far we know the impedances between the points A to G as well as B to G. That's it. Okay. Now for DC first I want to take, see, ripple factor I want to calculate. Ripple factor is RMS value of AC component by DC component. First I am going to try to get the DC component. For DC component, for a DC, inductor is short circuit, because for DC means frequency 0. So inductor is short circuit and capacitor is open circuit. We know that. Capacitor is open circuit. Okay. Now I am applying these two on this. Then I get the equivalent circuit. Therefore, DC circuit is DC circuit. Vm by pi. Now that AC component is 0 because we are taking DC circuit. It is Vm by pi. So your capacitor is, inductor is short circuited and capacitor is open circuited. And at output we have a load RL. At output we have a load RL. Now this is the DC current flowing through that. DC current flowing through that. IDC. Therefore IDC is, from this, IDC is Vm by pi RL. That is the value of IDC. Next, I want to get a AC component and its RMS value. For that I am taking AC circuit. For AC circuit, DC component I am taking to 0. DC component what we have is I am making this one to 0, and AC value, AC signal, AC voltage, this is the equivalent circuit, and your inductor is there, here capacitor is there, and here load resistor RL. This is point A and this is G, ground. This is L, XL reactance, XC capacitance, reactance of the capacitor. Now due to this AC voltage, it is AC voltage. AC current is flowing through this. IAC is entering into this. Now this total thing can be replaced by like this. This is AC component, this is the point A, this is the point G, and between this we can place the impedance between A to G, ZAG. Now this is the AC current, it gives the AC current, IAC. Okay, now we can write IAC is equals to VAC by ZAG. Therefore IAC equals to VAC by AC component, it is AC value, by ZAG. Now just hold that value, IAC value, hold it. Okay, now so next one is, so once this AC current is flowing to this, see, once you are connecting a capacitor like this, here voltage division takes place. That's why we are taking everything, instead of taking currents, in previous case we taken I dash RMS by IDC, but this time we take VDC by V dash RMS by VDC, because by connecting a capacitor here voltage division takes place. So from this we can write VDC value is, so we need VDC value is Vm by pi. So this is the point we need. Now this is the AC current entering. Now this AC current is entering like this, AC. So once this AC current, this is the point B and G, this AC current is entering into this. Now here at output I get the AC component. Now I'm moving to the next circuit. So the circuit what we have is, this is the AC voltage, Here is the inductor. This is the point B, and this is the point ground G. Between here you have impedance between B to G. So your AC current is flowing like this. Now once AC current is flowing through this, there you get I dash RMS. RMS value of that AC component is flowing through this. Now it results output, we get the V dash RMS voltage. So V dash RMS is I dash RMS into this one, I dash RMS into VG. Okay, and we know that impedance between base B to G, so that is I dash RMS into impedance between that one is it is XC. You know that. Now I am going to taking the value of I dash RMS. So we know I dash RMS. I dash RMS is IAC peak value by root 2. IAC peak value by root 2. Now we know already IAC value. IAC current is VAC current by ZAG. So VAC is, we know that Vm by 2 sine omega t. From this is by, it is by ZAG. So impedance between these two is XL. Therefore IAC component is Vm by 2XL into sine omega t. This is IAC. Now IAC peak value is Vm by 2XL. Just take this one, substitute here. Therefore Vm by 2XL into 1 by root 2. That is the I dash RMS. So that is Vm by 2 root 2. Vm by 2 root 2 into 1 by XL. Now V dash RMS value is I dash RMS into XC. Just take that XC value, I dash RMS value, substitute here. Now it is Vm by 2 root 2 into XC by XL. XC by XL. Now just write finally. Therefore V dash RMS is Vm by 2 root 2 into XC by XL. And already we know that VDC is Vm by pi. Therefore ripple factor is gamma equals to, so ripple factor gamma is equals to V dash RMS by VDC. So which is V dash RMS is Vm by 2 root 2 into XC by XL by Vm by pi. Vm gets cancelled. Therefore ripple factor is pi by 2 root 2 into XC by XL. That is the ripple factor. And one more thing here is where XC is where XC value is 1 by omega C and XL is omega L. Fundamental frequency component is present. But in case of full wave rectifier, second order harmonic component is present. 2 omega is present. This is the filter, L section filter. We applied that one to half wave rectifier. Okay. So this is about your L section filter. And here we have to discuss one more topic in L section filter, blader resistor. Okay, so in full wave rectifier we highlight the topic of blader resistor. Okay, blader resistor concept we applied at full wave rectifier case. Next one. Next we have one more filter, that is a pi section filter. So this is the procedure to apply a filter section to half wave or full wave, anywhere you can apply, but this is the procedure you need to follow that. Okay, now next we are going to take you to the pi section filter or CLC filter. Now fourth one is CLC filter or pi section filter. Pi section filter, CLC or pi section filter. Simple thing. Similar to the previous case, just to take the half wave rectifier first. Here is connected to AC mains. And at output I am going to connecting the AC section filter, CLC filter, pi section filter. So here we have one capacitor, here is inductor, load RL. This is the way of designing the filter section. Let us take it is a C1, it is a C and L. So here my intention is to split this one into different parts. This is simply capacitive filter. C section, it is simply C filter or C section filter. This is L section filter. Okay, two halves, two filters we are using. That is nothing but a pi section filter. So what are the concept we applied in half wave rectifiers filters? The same concept we are going to be applying here. Okay, and now we know the voltage at this point. See this? Now voltage across capacitor is going to be this is capacitor. Okay, now this voltage is, let us take VC1. Voltage at the capacitor is VC1. Now that means this is equal to the capacitive filter. Now this is the plot for VC1. Plot for VC1. Under steady state conditions, plot is like this. So capacitor charging, discharging, capacitor charging, discharging. This is the plot at voltage across capacitor C1. Voltage across capacitor C1. Okay, now by applying trigonometric Fourier series, what I am doing is I am going to writing the expression for this one. Okay, now the voltage at this point VC1 is DC component VDC minus V gamma by pi into sine omega naught t. Sine omega t or omega naught t or omega t. Previously what we use, just use that. Sine omega t. That is the DC component minus Vm by pi into sine omega t. V gamma by pi. This is V gamma. Peak to peak value of this one is V gamma. This is V gamma. Simple thing. Okay. Now DC value of this one is already, we know that. We written the DC value of this. Now for this, from this waveform, DC component already we've written. VDC value is Vm minus V gamma by 2. This is the DC component here. Okay. And V gamma value is, already we derived, it is IDC by F operating frequency into capacitor C1. This is the V gamma value. So far we know the values of that. Now this signal is passing through L section filter. The way how we taken, now let us, this is point A, this is ground, this is point B, and this is ground. The same procedure what we followed previous case, I'm going to following the same procedure. Okay, but the only values are going to be changed. Peak value is this one, V gamma by 2. This is the DC component value. Okay, so by following all these things, directly I'm going to writing that equation based on the previous knowledge. Okay, so see here, now we have here, this is the VC1 voltage equation, VDC minus V gamma by pi sine omega t. Here VDC value is Vm minus V gamma by 2, where V gamma is IDC by F into C1, capacitor 1 we are using. Now this is applied as input to the LC section filter. Okay, so applying this one to L section filter. So once we applied this one to L section filter, so the required value of VDC is the same one, no change. Now this VC1 is applied to L section filter. L section filter, connecting a load RL. This is VC1 we are applying. VC1 applying. Okay, now VDC value is simply whatever the VDC you have already, that component. Okay, so no change in the DC component. Okay, later we go to that DC component part. First we analyze this with VC1. Now during this analysis, already we derived just before V dash RMS is equals to V gamma. See this, it is I dash RMS into, this is the current flowing through I dash RMS. Here you getting the IAC current. The RMS value of this component is this one. So I dash RMS into XC, because XC is much less compared to RL. Now I dash RMS is IAC peak by root 2. Therefore IAC peak by root 2 it is. IAC peak value by root 2 into XC. That IAC peak value is simply VAC peak by impedance between A to G. Impedance between A to G is XL simply. So it is VAC peak value by XL into root 2 into XC. So VAC peak value is here Vm by pi. Therefore finally V dash RMS is VAC peak value Vm by pi, V gamma by pi into root 2 into XC by XL. At the same time V gamma is having IDC by FC, F into C1. So IDC by F into C1 into pi, sorry, here pi into root 2, here XC by XL. Simplifying this just. Now this is the IDC value we have. Now I'm copying this for next. See, now this is the value what we have so far. Now V dash RMS I am writing as IDC is, we know that VDC by RL, VDC by RL into XC by XL. Here you have, just I am separating that first, XC by XL. Next 1 by F is there, just it is a F. Next one is root 2 is there here, just I am keeping root 2. F is over, root 2 is over. Now I do one thing. See this? Root 2 I am keeping here, okay. Next pi F C1 I am keeping here. This is the value 1 by. Now just check the things, all are covered or not. IDC is VDC by RL. Here 1 by root 2, 1 by root 2. Pi FC1, 1 by XC by XL. Fine. For my easy purpose, what I am doing is I am going to be multiplying and dividing it with 2. Multiplying and dividing with 2. Now can be written as, just take VDC this side simply, VR dash RMS by VDC. We can call it as a ripple factor is 2 by root 2 into 1 by RL into 1 by 2 pi F C1, 2 pi F C1 into XC by XL. Here we have 1 by 2 pi F C1. I am writing it as 1 by omega C1. Omega is 2 pi F, you know that. Now I am writing simply it is XC1. Now this part can be written by XC1, therefore it is, and that 2 here, this one cancelled in this, it became root 2. Now it is root 2 into xc1 by, here xc1 by RL into xc by xl. This is the equation for ripple factor. Final equation for ripple factor. This is the procedure you need to follow to calculate the ripple factor. So ripple factor is root 2 into xc1 by RL into xc by xl. This is the procedure you need to follow to calculate the ripple factor. So far we completed half wave rectifier with 4 types of filters. But in competitive examinations, you need to give equal priority to half wave rectifier as well as full wave rectifier. Okay, because at outside in most of the textbooks they given, and they are giving priority to full wave rectifier only, not a half wave rectifier. Practical applications point of view, full wave rectifier, no doubt at all, but in examination point of view you should be thorough with both the half wave as well as full wave. So my dear students, please think once of it, okay, and take a right decision. Clear? Now this is about your half wave rectifier with a complete filter section. Clear? Okay. So next session we go and discuss about full wave rectifiers. Thank you very much. Thanks for spending your valuable time with us, and don't forget to use our code VRAO10 during subscription, a code to get 10% discount. And please subscribe us, and please give your valuable comments, and join our Telegram group to get the latest updates on our upcoming videos. And don't forget to give your comments. And once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Okay. Next session we discuss about full wave rectifier with filters. Thank you very much. Thanks for spending your valuable time with us. Thank you.